Hi there, this is Coffee Code Repeat again with another video tutorial. Today I'm going to teach you how to solve for the determinant of a 4x4 matrix. So the method I'm going to show you is a recursive method, and it can be applied to any n by n matrix. Alright, so let's dive into this example. Alright, so as you can see here, I've already drawn out this 4x4 matrix. What we're going to start by doing is finding the row or column with the most zeros. So you can see here there's a column with 3 zeros, and that's going to make everything a lot easier. So what we do is we take this column with the most zeros, start with the first element of this column. Notice over here I've drawn out a little matrix of positive and negative signs. So this is how we're going to determine which of the components is positive and which is negative, and you'll see what I mean in a second. So notice that this 0, this first element of this column that I've chosen, corresponds to this negative sign in this matrix of alternating signs. So we're going to take this and we're going to go matrix A, so this equals a negative 0. So in this case it doesn't really matter because it's 0, but it matters if it's not a 0. So negative 0 times, and then you're going to take every element that's not on this row, the same row as 0, or in the same row as 0, or in the same column as 0, and you're going to put it in this new 3x3 matrix. So everything in the column, everything in the row, everything else is 1, 0, negative 2, 4, 6, negative 3, and 5, 2, and 0. So since they're not in the same column as 0, this 0, or in the same row as this 0, they're going to go into this matrix. So it's going to be 1, 0, negative 2, 4, 6, negative 3, 5, 2, and 0. Okay, so that's going to be the first component, and we're going to do this with every other element in this column that we've chosen. So we're going to go to this 2. See, it's a positive here, it's a plus. I'm going to go plus 2 times, and then everything that's not in the same column or row as this 2. So it's going to be 3, 2, negative 1, 4, 6, negative 3, and 5, 2, 0. So we're going to put that here. 3, 0, oh, sorry. It's going to be 3, 2, and negative 1, 4, 6, negative 3, 5, 2, 0. Oh. Okay, so we're going to do that with these 2 remaining zeros. So they're zeros, so it's going to get zeroed anyway, but I'm just going to show you what it would be. So it'd be everything that's not in this row or column once again. And also you're going to look here where it corresponds. This is a negative sign, so we're going to go minus again, 0 times 3, 2, negative 1, 1, 0, negative 2, 5, 2, 0. Yeah. And then the last element is 0. It's going to be positive, plus 0 times, and then everything that's not in this row or this column, 3, 2, negative 1, 1, 0, well, that's a bad 0, negative 2, and then 4, 6, negative 3. Awesome. So since this is 0 times, oh, and so I should add, these matrices, this symbolizes kind of the determinant of this matrix. So what this kind of says is these 4 components that we've broken this 4x4 into is going to be 0 times the determinant of this matrix plus 2 times the determinant of this matrix minus 0 times the determinant of this matrix plus 0 times the determinant of this matrix. So I'll break that down further. But since these are zeros, we can instantly eliminate these, which makes computing this whole thing so much easier. Because if I chose, say, this column right here, I would have to find, it would be a 3 times the determinant of this matrix, 1 times the determinant of some other matrix, 4 times determinant of another matrix, plus 5 times the determinant of another matrix, which would make it incredibly difficult and tedious to calculate. Here I only have to calculate the determinant of 1 3 by 3 here, as opposed to 4. So I'm going to continue. So it's going to be 2 times the determinant of this matrix. So what we're going to do is we're going to do the same exact thing. We're going to pick a column or row with the most zeros, and so in this case we're going to pick this row right here because these are negatives and I don't want to deal with those. So we're going to have this 2 outside times, and then we're going to take this first element, 5, which is, let's actually look up here for this 3 by 3 positive negative matrix. So this is positive, so this one's going to be positive, 5 times, and then we're going to take the determinant of the matrix that it consists of all elements that are not in the same column or the same row as this 5. So that's going to be 2, -1, 6, and -3. It's bad 6. Looks a little better. And then we're going to take this one. This is a 2. As we can see over here, it's negative. So -2 times 3. So yeah, everything that's not here or here. So 3, 4, -1, and -3. And then this last one's going to be a 0. So I'm just going to put plus 0 times and then some determinant. So we can eliminate that because it's 0. Then we're going to solve for these. So to solve for 2 by 2, the determinant for a 2 by 2 matrix, it's pretty simple. You just take the product of this diagonal minus the product of this diagonal. Okay, so this is going to be 2 times -3 minus -1 times 6. And then we are going to do the same thing with this component right here. So -2 times the determinant of this matrix, which is going to be 3 times -3, which is -9, minus -1 times 4, which is -4. That's going to be plus plus right here. This is -6. 2 times -3 is -6. Oh, sorry. Well, 5 should be times both of these. So -6 minus -6, which is 0. So this all goes to 0. So it's going to be 2 out here times -2 times, and then this is going to be -5 times -2 is 10 equals 20. So this is going to be your final answer, the final determinant of the original 4 by 4 matrix. So just remember, this recursive method can also be applied to any n by n matrix, which is why it's so valuable to know how to actually implement. Also, another note, another thing you should remember is just to, at the very beginning, make sure you choose the columns with the most zeros, or the column or row with the most zeros, because it's going to make your life a lot easier down the road. Like we saw, we eliminated a lot of components and a lot of work by doing that. Anyway, thanks for watching. I hope you liked the video. I hope you learned something. If you did, please like and subscribe so I can keep making more videos. If you have any feedback for me, please leave it in the comments below so I can learn how to make the best video possible for you guys. And until the next video, coffee code repeat. See ya.